Okay, class, in this video I'm going to go over log files and the NTP service, which is Network Time Protocol. So I'm going to use the book to kind of show you some things. Now each application can have its own log files, but the log files that I'm going to be talking about is the system log files. Var log messages, this is where most of our messages for system related things are going to be stored. It's kind of when you have an issue, you should go here. It should be like second nature. The var log secure file is used for security related events or people logging in or logging off or failed logins. If someone's trying to hack your server, and logging in a bunch of times with different passwords and failing, that's where you would look. This is if you have a mail server set up and there's one always running in the background. This is where you would see system related events to the mail server. And the var log cron is for scheduled tasks. If you know the AT command or the task scheduler in Windows, this does the same thing. At certain times of the day, you can have certain events happen, and this is where you would see logs related to those events. And the last one is var log boot.log, and it's basically when your system booted up, if you had any issues during that time. These log services are being provided by something called rsyslog. I believe R stands for remote. I could actually have all my computers connect to one machine and put all the log files in one machine. And if I wanted to, I could go to that one machine and see all the logs for all my servers. So right now we're only going to be dealing with it locally, but you could set up one machine as a syslog server, and at that point, all the other machines will connect to that machine and send all their log events to it. And that's where you would go to look at those log events, as opposed to go to each individual server. Now, one thing about the log files is people don't look at them enough. Your system has taken all this effort to make sure it notifies you, and if you don't look at the logs, they won't do you any good. So it's good to go through the logs at least once a day, because if you don't go through the logs, you won't know what's going on with your system. If someone's trying to hack you and you don't look at the security log, you'll never know someone's trying to hack you. Okay, guys, this facility is kind of like I'll go over the level on which the it's hard to explain what the facility is. On the next page, I'll go over. We have facilities and we have priorities, and I'll go over each of those in the next screen. But I'm going to go to my system. I'm signed in as student right now. Sorry, who am I? If I try to cat var log messages, I'm denied. We have to review these as root. So I'm going to sign in as root, and then cat var log messages. So you have to be as root when you do these things. So I'm also going to list var log. You can see all the log files that I have. There's a bunch of different log files, like this DNF log file is for the application yum when we install stuff. So that's an application log files. Now this mail log is a system log file. This last log is also a system file, but we're not really discussing it in this video. So I'm just going to do the command last. It shows you who logged in and when the system was rebooted, things like that. That's going to be stored in the last log, cat. You see how it's kind of encrypted? Well, if you wanted to view that data from that file, you just do last. I'm surprised the book never really talked about the last log, but it doesn't. So I'm going to do list again, var log. So what we're going to be dealing with is the boot log, the cron log, the message log, and the secure log. Those are the ones the book wants us to go over. Oh, plus the mail log. So I'm going to go to the next page. This is chapter 11, incidentally. Okay, so we have these priorities: emergency, alert, critical, error, warning, notice, info, debug. And then we have these facilities: auth, priv, priv. Let me pull them all. They don't really list them here, but like local 7. These are. This is a facility. This is a priority. This is a facility, and for this, it's all priorities. So, like, kernel would be the application that's generating it, or auth privilege is the application that's generating it, or mail is the application that's generating it. That's the facility. Cron, which is our time scheduler, that's the application. So, kind of think of the facility as the application that's generating it, and the priority as the level of that issue. So it'll be emergency, alert, critical, error. So it's going to be facility dot priority. So the application and the level in which that log is has. So it might be just a debug log for the mail application, or it might be an error log for local 7, which is this kind of like a system. And you have this file, etc rsyslog.conf, and it tells the system what to do with those log entries. So if it's kernel dot and any priority, it pops up on your console. If it's any application dot info or mail dot no priority, or auth privilege dot no priority, or cron dot no priority, then it goes into this file. So this config file is just used to kind of direct where messages go. So like kernel log files are going to go to the console. Anything from any application with the EMERG is going to go to this location. Anything local 7 dot asterisk will go into this location. So it just kind of redirects where the log entries are going to go based on the facility, which is the application, and their priority. Log files are normally rotated. When a log file gets full, it copies the old log file into another file and gives it the date, and then new entries will go into the var log messages. It'll create a new file. So basically, I'm going to go back to my system, and you can see like this mail log. It got full at one point in time, so it moved the mail log to mail log 2020-0330, and then created a new mail log folder for new entries. It's called log file rotation. So it doesn't really delete the old log files, they just kind of sit here so you can go back through them should you need them. Now when I look at a log file, I'm going to pull a log file up. I'm going to do tell var log messages. All new entries go at the bottom of the log file. So by running tell, I'm going to be looking at the last 10 entries. And then you have the date, the system that that event has occurred, the date, the system that it occurred, in our case, VM1, the application and program ID that generated that error. Right here would be the application and the process ID that generated that error, and the message itself. Do you remember when I said you can set this machine up as a syslog server and receive all the log files from all the other servers? So that's kind of why they put the server name in here, because remember, I might be looking at the event logs for hundreds of machines. So it's important to know which machine you're dealing with. And all the log files are kind of that way. So cat var log secure. Again, there's the message, there's the date and time, there's the machine it was generated on, there's the application and the process ID that generated this event, and then there's the actual message itself. So it's telling you how to monitor those logs, and when someone logs in and something, they're having you sign into one machine, looking at a log file and seeing that someone signed in. So if I do su-student and enter, I'm going to type exit again, and then I'm going to do tell. I'm just only going to look at the last 5 events. Var log secure. I can see that I signed in, then signed out as student. I could manually enter a log in the entry. So I could do logger -p, and what I'm going to do is they're having you, the example the book is giving you is doing a local 7.notice, which will be, I scroll back up here, local 7 is just like a local machine message, and a notice would be a priority of 5. So I'm going to do a kernel with a priority of error. So I'm going to do kern.error test message. Cat var log. And there it is. There's my test message. I don't know why it's not coming up on the screen in this environment, but if I SSH to another box and do it, student, I'm going to sign in as student VM1 on the other machine. Sorry. SSH student at VM2. And if I do a logger -p kern.error test message, it's still not coming up. I'm not sure why it's not generated on the console. This is not something I do all the time, but according to here, it should be coming up to my console, and it's not. I'm not sure why. I've done it a few times, and every once in a while it'll work, and I'm not sure what I'm doing differently. But what it's doing is it's creating that entry. I'm just going to look at tail dash and look at the last 5 events for var log messages. Sorry, I have to be signed in as root. Tail dash n 5 var log. Excuse me. I'm sorry. I hope that's not too loud. Maybe I need to go back more than. There's my test massage. But there is my entry right there. If you're doing something and you want it to be part of the log files, just use the logger command. I've never really had to use it in a production environment, but you know, it's there. It's nice to know about. Okay, now I want to show you another command to look at all the log files. On the last video, I showed you about a command called system system control status sshd. And then at the bottom of that, it will show me all the log events from var log messages for that application that I'm dealing with. So in this case, I'm looking at SSHD. So instead of looking at the log files themselves, I can run this command for an application and see all the log events for that application. So I'm going to hit Q to quit to get out of this, because it might be 2 or 3 pages long. In this case, it was only 1 page long. Or I could use the journal command. Journal control. And also look at all my log files that way. I could get very particular and specify just the last 5 lines, or the last 10 if I use the dash F. Or if I wanted to, I could look at only errors. I can specify priority dash P error and just look at only errors. Again, hitting quit. So if I want to look at, let's do a, let me go back one. I'll go back a couple pages. So let's say we're going to do a alert. So I'm going to do logger. Priority will be for the local 7 app, my local machine, and I'm going to do, what did I say? An alert. Dot alert. And then use journal to view alerts. There's my alert. So this journal command is nice. There's a lot of other things you can do with the journal command. You can view logs at a certain date. Let me get to that page again. So you can look at the last 10 or a certain number of logs. You can look at priorities. You can look at since today or since another date or for the last hour, or be very verbose by doing -O, and it not only will give you a log, it'll give you as much information about that event as possible. Or I could look at a particular service. So if I wanted to only look at SSHD stuff, I could do underscore systemd underscore unit equals SSH dot service. Or I can go by the process ID if you know the process ID of that service. So it's a pretty good utility. I'm kind of old school. I still go to the mainly Kata files, but this has been in place for a few years now. I just haven't gotten on board, but it's a really nice utility. So when you read the book, chapter 11, you can practice all that stuff. Just a lab for that topic. Okay, so some log files are automatically going to be deleted, or some log entries are going to be deleted when you reboot your machine. And that might not be a good thing for what you want to do. So you can change that so all logs are persistent, meaning that when you reboot, you're going to keep those logs across reboot. Or volatile, meaning when when you reboot the machine, at that point, they're going to be erased. Or auto, let the event determine whether it's going to be kept after reboot or be deleted at reboot. Right now the system is set to auto, but you can change it to be persistent so you can keep all your log files, or you can change it to be volatile so everything is deleted every time you reboot. In really secure environments, you might want to go with persistent because at that point it keeps all of your log files. And it also keeps all of the information about your boot. Well, it will keep stuff about your boot, but all that stuff is this historical data is available right after you reboot. So guys, to change that, we need to edit this file. So I'm going to go to vi etc systemd / or journal D. All these services that run in background, they end in D for daemon. So I'm going to edit the config file for that. And you would change this from auto. So I'm going to YY copy that line. I type YY, I hit P for paste. I'm a firm believer about not making changes to these config files. So I would keep my current line as it stands, copy it, remove the hash, and you can change this to whatever you want. So I'm going to do a Shift A. I can't spell persistent. And at that point, my log files would be kept after reboot. Guys, any entry that begins with a hash mark is a comment. So they give you all these things that you could set, but they comment them out just so you know what the term is, so you don't have to go look it up. So I would copy it, uncomment it out, change it to what I want, then escape, :WQ to save it. And then you would have to restart that service. System control restart journal D. or restart journal. Am I spelling it wrong? I'm going to try to tab complete. I'm not sure what the service is. All system D, journal D. Okay, and that would restart the service. I'm not sure if this has the ability to reload the config file by typing reload. No, it doesn't support reload. So in this case, when you change the config file, you have to restart it. Again, I'm not a big journal fan just because I've been doing this for so long. So go through, read this book. There's some additional things I'm not covering, but you should be able to get the gist of what you're reading after this lesson. Okay, the next thing we're going to cover is our time clocks. Every motherboard has a little silver tube with a crystal in it. That is used, and they run a voltage through it, and that is used to keep your computer timed. It's like the guy in the front of a row team that sits there and beats a drum so everyone can stay on time. The problem is when they grow that crystal, they don't always grow identically, so you have something called time drift or time creep. So basically, we have the service called NTP, Network Time Protocol. What it does is it allows us to sync our machines against a network time clock, like the Navy time clock or something like that. But we're going to be using the Red Hat time clock. It's kind of rude to use the Navy time clocks. You should really sync your time to either like Red Hat or Windows, or sync it to your ISP's time clock, and then only they should sync to the Navy time clocks. So basically, we have two things we can set here. We can set who our time zone, because remember, we're in the area of -5, and you can also set which time servers you want to use. So the first thing we want to do is set our who we're sync our time zone. So I'm going to go here. I'm going to do time date control. If you just do it alone, it shows you what you're currently set to. Currently, I'm synchronizing. I'm going to an active time zone. I'm not looking at a local clock. I'm just using this service to go to a network clock. So time, date, CTL, list, time, zone, zones. I'm going to hit the up arrow. Guys, I'm going to grep for New York so we don't see this big long list, because this list is huge. So there's the time zone that I want to use. So I'm going to do time, date, control, set, time zone to America, New York. And so when I run time date control, I can see my time zone is set to New York. Right now it's because we're daylight savings time, it's actually a -4. We're 4 hours off the Greenwich Mean Time, the time from England. Okay. I could use it to set the time if I wanted to, but again, we shouldn't have to set the time because we're synchronizing to a time clock. The whole point of NTP is not having to manually set the time. I could choose not to use NTP and say time date control set NTP to false, and then manually have to deal with the time myself. but I'm not sure why anyone would want to turn this nice feature off. Chrony is an application used to maintain your clock, your time clock. It's going to be the service that actually does all the syncing and stuff like that. So chrony D is the daemon, chrony C is the client software. So basically, we have this config file, cat etc chrony conf, and I could configure. I'm going to the top of the file right here. Who I'm going to synchronize against. Right now, we're synchronizing against a Red Hat time server network. So, guys, if I didn't have pool here, that means I was synchronizing to one machine out in the internet. By doing pool, it's going to show me a list of a bunch of servers that I can synchronize against. Here it's going to record in this file how far off I drift from the time. And there's a lot of things in this file I'm not going to go over. But I could allow, if I comment this out and put my network here, I could allow other machines in my network to synchronize against me. So instead of all the machines going out to the internet to synchronize their clock, I can have one machine synchronizing the clock, then everyone in my network connect to me to synchronize. And if I am a time clock, when do I want to stop synchronizing? Basically, the stratum means how long your machine has been up as a time clock. The lower the stratum, the more that machine has been trusted. So when you boot up your machine, it might be stratum 10, and it might be 3 weeks before it gets down to stratum 2 or 3. So the lower the number, the more trusted it is. So when you make a change to who you want to synchronize against, like right here, the lab that the book wants you to do is synchronize against a machine in your network. So instead of being, let me go back to this file. So they want you to change this line in this file. I'm going to do head in this file, so I'll look at the first 10 lines. So they want you to edit this file at etc chrony y, chrony conf file, and then change this line right here. So instead of going by a pool of servers on the Red Hat network, they want you to go through and change it to one individual server, and they give you a name of a machine in your network. Don't bother doing this. I'm just going to leave mine pointed to the Red Hat time servers. But if I had a bunch of servers in my network, I would set up one to be a dedicated time server, and at that point, have all the other servers synchronized to that one machine. So the machine that's acting as a time server would synchronize against the pool. You would then go and allow the computers in your network to access this time clock. And then on all those machines, you would say server and then your time server in iBurst. And at that point, everyone will sync against your time clock. We could also look about our current servers. So we would use the chrony client, chrony C server, and then verbose, not server, sources. So right now in that pool we have, let's see, 210. We're using 4. These are the 4 time servers that we're using from that pool. And it's telling you whether it is a server, because it's a caret symbol, versus a peer, versus a local time clock. And it's telling us, see the minus means that it's not combined. I don't know what the combined means. If it was an asterisk, it would be current and synced. I'm not sure what the combined means. But the stratum for those clocks, this one is a 2, this one is a 1, this one is a 3. So those time servers have been up for a while. And it's going to automatically adjust by a certain number of milliseconds or offset, because remember, when I get the time from the time server, it's going to calculate how much time it's going to take for me to receive that packet. So it's going to adjust that accordingly based on how much time it takes the packet to travel from the time server to me. This is something you don't configure very often. You configure it once and you never touch it again, but it's nice to be aware of what's going on with this. And I'm just going to go through the rest of the chapter to verify I'm not missing anything, and I'm not. Okay, so guys, we did a little bit of log files, a little bit of our NTP service. Read the chapter, follow along with this video, and you should be fine. Okay, that's it for this video. Thank you.